Hey guys, Jake here, coming at you with another math lesson today. Today we're going to be talking about polynomial long division. Basically how you can take some longer, higher degree polynomial and divide it by a smaller, slightly more simple, lower degree polynomial. I'm going to be giving you the step-by-step guide in this video so that you can master this process and apply it to any other problem. If that sounds good, be sure to stick around to the end of the video. And without further ado, let's go ahead and jump on into it. Use long division to divide 5x squared minus 17x minus 12, all divided by x minus 4. So you may be looking at this and thinking, wait a minute, can't we do synthetic division here? Which is, if you don't know what synthetic division is, it's basically just kind of a shortcut that you can use instead of doing this polynomial long division process. Specifically, whenever you're dividing a polynomial by a term that is just x plus or minus some number, or whatever your variable is. So yeah, you would be right. We should be able to use synthetic division here. I'm going to show you how to do this one as polynomial long division, because that's what the problem asked us to do in this situation. But I am going to be coming out with some videos in the near future that show you how to do synthetic division so that you can apply that shortcut instead. So if that sounds good, be sure to hit that subscribe button down below and that bell icon so you're notified when those new synthetic division videos come out. They'll be coming out soon. But let's go ahead and apply polynomial long division to this problem. So basically what I recommend doing is just writing out the polynomial that you're trying to divide, and then kind of like, normal long division, you can just put that inside the divisor symbol and then put your other polynomial that you're trying to divide it by out here, just like you're doing long division with a long number and a smaller number, right? So now when we're actually jumping into doing this long division, you pretty much just go one term at a time and think about this, starting with your biggest degree x term first and moving toward the smaller terms. So that's one thing to keep in mind. If you are given a polynomial that doesn't have your highest degree first and then in descending order from there, you want to reorganize your polynomial so that it starts with the highest power x term first and then goes to your next lowest power x term and then your next lowest power x term, and so on and so on and so on. If there's more than 3 terms, that may go on a little bit longer, but basically you just want to put it in order. And same with this one out here, you want to put it in order using the same method, because you're going to start by looking at the highest power x term first. So in this case, we have 5x squared here. Now what you want to do is compare that to just the highest x power term out here. So basically you're looking at both of them, just the highest powered x term. And all you want to do is think about how many times, or if you did this term divided by this term, what would you be left with? And in this case, if we did 5x squared divided by x, that would simplify down to 5x, right? This x would cancel with one of these x's and we would just have 5x. So what you're going to do is you're going to write 5x right here. Then what you're going to do, kind of the second step to this process, is to take whatever this polynomial is that you have right here and then multiply it by both of the terms or all of the terms that are in this polynomial here. So we're going to go 5x times x, and that would give us 5x squared again. So basically you're just going to write 5x squared right here. Then you're going to take 5x times negative 4. So be careful to kind of maintain the signs if you have any negative signs. 5x times negative 4 would give us minus 20x. So you're just going to write the product of multiplying this term by each of the terms over in this polynomial here directly beneath this. Then, just like long division, your next step would be basically to subtract this whole polynomial from whatever you have up above. So be very careful. Make sure when you do this subtraction, you put parentheses around all these terms. If you're not putting parentheses, your signs are not going to end up working correctly. So we'll just kind of go one term at a time. It should line up nicely so that you have the exact same powered x that you're subtracting from. So 5x squared minus 5x squared is going to give us 0. And then negative 17x minus negative 20x, be careful there, negative 17x minus negative 20x is actually going to be the same as negative 17x plus 20x, which is positive 3x. So we're going to get plus 3x down here. And then whatever terms you have left up here that you didn't subtract like this, you're just going to carry down. So we're going to have a negative 12 out here. Okay, so now we have this polynomial, 0 plus 3x minus 12. The 0 is not really doing anything, so I'm just going to erase that. So now we have 3x minus 12. And now we just repeat the exact same process using this polynomial instead of how we use this one. So we're just going to start by looking at the leading x term, the 3x, and then divide that by the leading x term over here. So 3x divided by x is just going to simplify down to 3. So we're going to write plus 3 up here. Then, again, we take the 3, the plus 3, and multiply it to both of these terms down here and write the result down here. So we're going to get 3 times x gives us 3x, and then 3 times negative 4 gives us minus 12. And then exactly the same process one more time. We're going to do minus, in parentheses, this whole thing from this whole thing. So 3x minus 3x gives us 0. Negative 12 minus negative 12 is the same as negative 12 plus 12, which gives us 0. So in this case, there's no remainder. If you do this whole process and end up all the way down here at just 0, 0 plus 0 is just 0, then that tells you there's no remainder. And doing the polynomial division that you started with, so this big long polynomial divided by this smaller one, will leave us with whatever's up here. If we get down to this point here, where we just had some number that doesn't have any x's in it, and therefore would not be divisible by x, then we would have a remainder. Now I'm sure you're feeling a bit better about how to do polynomial long division problems, but there's a little more to it, and you're definitely going to want to check out this next video. I'll come back and put it over here. I'm going to be dropping that video in a couple of days, so if you're watching this just right after I posted this video, be sure to go hit that subscribe button, hit that bell icon, turn notifications on so you don't miss it, but I'll come back and put it right over there as well if you are watching this later, showing you how to do a slightly different type of problem that is still in the realm of polynomial long division. You're definitely not going to want to miss it.